So Aparna, you have solved 2019, so you can should ask something from there.
Yes, sir. So it's question number 7.
Okay, so this is 2019, question 7.
Let A be equal to, like it's a set, 1, 2, 3 till 17. For every non-empty subset B of A, find the product of the reciprocals of the members of B.
For every non-empty, so non-empty is fine. B of A, find the product of the
Yes,
reciprocals.
of the members of B.
Product of the members of B. A product of the reciprocals of the members of B.
Find the product of the reciprocals of the members of B. Sir, actually, after that, they were asked to sum all the products.
Yes, because otherwise it doesn't make any sense, right?
Yeah.
Yeah, because for different sides you will get different answer, but when you sum it, then it's interesting. So find the sum. Find the sum of all such products. So let us just give a few examples. It's suppose if P is equal to 2, 3, right? Then for this, the product will come out to be this. And for example, you understand. So you have to do this for every B, every subset B, all the 2 to the power 17 minus 1 subsets. And then you have to add. So for example, if it is 2, 5, 9, then I don't know how to add it. Let's see. So find the sum. So, sorry. I don't know. So there will be some kind of maybe factorization, right? Or you can even do some kind of recursion. I think recursion is not bad. Recursion is not bad, right? So if what I'm trying to say is that if we call this sum as 17, right? If you call this sum as 17, then in S17 there are many terms, 2 to the 17 minus 1 terms. If I look at those terms which have 1 by 17 in them, and then I look at those terms which don't have 1 by 17, then can I learn something?
What?
No? Right? Like this, because if I take out 1 by 17 from all of them, then what do I get? So you understand what I'm doing, right? I'm focusing on those things which have 1 by 17. I just write a few examples. For example, 1 by 17 is one of them. 1 by 17 will in fact come twice, 1 by 17 and 1 by 17 times 1, right? Maybe 2 times 1 by 17 and so on and so on, right? If I take out 1 by 17 from all of them, then what do I get? Do I get S16? Do I get S16? Right? I will get all the products that don't have 17 in them. Right? I mean that 17 they don't, like the 17 that they, because 17 is the prime, so it's the same thing, but they won't count for the subs. They will basically correspond to subsets that don't have 17.
Yes.
Right? So you can do it systematically for every subset that does not, for every subset of A that does not have 17, write a product, it will appear in this. But it has something extra. It also has an extra 1 in it. Can you tell me why? Because you see, the 1 by 17 that we gave for this set, now that becomes a 1. When you pull out the 1 by 17, now that becomes a 1, and that is for the empty set. So that extra 1 will be there. Is that fine? Okay. So we will change, right? So we will change the question a little bit. I will not write non-empty. I will say let's consider all subsets. And for the empty set, I will always map it to 1. Empty product, I will write 1. So I will create a term for my empty set also, and that will be 1.
Sir, 1 by 17 was counted twice, so won't it be 2?
No, because one of the 1 by 17 was from here. And this will become 1, but this will now be for the subset 1, right? So you see, so there is a 1 by 17 here, and there is a 1 by 70 that comes from this. Okay. Now this one, when we take out this 1 by 17, then this 1 by 1 that we get, this corresponds to the subset 5. And this, when we take out 1 by 17, this corresponds to the subset 1. But that we are not actually overcounting. The second one we are not overcounting, because we have to count it anyways.
Yes.
Okay, that is in the definition. Okay. So we change the definition a little bit, that it's for all subsets. Then according to that, it is S16 exactly. Okay. So this will become 1 by 17 times S16. I hope everybody is following this. And then what about this one that don't have 17?
Plus 1?
Sorry, Nagesh, can you turn up your volume? Yeah, okay. So Yeah, just turn it on when you speak. So now, what do we do with the other terms? So they don't have 17. So that is also as 16. But it is as 16 minus 1 according to our definition, because here the empty set was not counted. No, it was counted. Yeah, according to this, it is, yeah. Here we are counting the empty set. And so that empty set will be here. Right? For the empty set, we had a 1, and that 1 was here for the empty set. So it is x16. Any questions? No? So then we have the recurrence. Yeah, we should do this faster, but you see, because it has to be very, very clear. So that the point is, what does it mean by it has to be clear? I mean, I see it as that you should be able to repeat this. You should be able to at least repeat this at the minimum. You should be able to use this technique later on your own. Okay, not just for understanding this particular solution, but yeah, this, and then it is not difficult, I suppose. So it's 18 by 17. And now you can find the answer, right? Wait, yes, right? So then it will be S15 times, yeah, 17 by 16 and 18 by 17, right? And then you know how this will go, right? All the way to S1. S1 will be 3 by 2, right? Till 18 by 17. Am I right? And then what will we get? We will get S1 times 18 by 2, right? 18 by 2. And what is S1? According to our definition, it's 2, right? So we get, I'm getting S17 is 18, okay? So S17 is 18, but again, our S17 is going to be one more, right? We have one extra one for the empty set, so the answer should be 17. Oh, okay. The answer is 17. Probably there is an easier solution, but that is not to say that it will be easy to find that solution. But easy to find, probably not a well-defined term, but yeah. I'm getting 7. Is 17 an option? Let's know that. Is it even an option? Aparna, was this your question? Can you check?
Yes, sir, 17 is
Yes. Okay. So I mean, I guess if I was in an exam, I would have done it for maybe 2, 3, and see. Okay. So you see this solution, is it okay? Right? See, I'm using the very classic recurrence, right? I am using, maybe I'll say a little bit. Okay. I don't know how much of this extra things are useful, but I like to do it because just so that you can contemplate on this a little longer, and it's probably can be useful also if you take it seriously. The point is that when you look at the power set of n, so all this means is that same set, n means 1 up to n, and power set means all subsets of that. Okay, it's a very useful object to look at and good to be comfortable with this. The point is that very classically we have to break this up, right, into subsets that contain n and subsets that don't contain n. And basically that's all I had in mind. And then I was seeing what sums do they correspond to. Okay. I was thinking of another approach in the beginning, which will probably not work, but probably worth sharing. Because to me, I mean, you people are writing the exam and obviously, but also just, it's just good to know the different angles, not during the exam, but try to see what's going on. Okay. So you'll have all of these things, and so what I was thinking of is, how do I say, something like this. So like, see, so if you look at the number 2, right, then what is the highest power of 2 that appears in this? Can you tell? What's the highest power of 2 that appears in these, among these denominators? That should be easy. Just the 17 factorial or something. Yeah, I mean, it should be there only in the last one, right? That will be given as the highest power. Something, right? Whatever it is, let's say you can calculate it. 17 by 2, 17 by 4, taking the floors. 70 by 16, so whatever, 8, 8, 4, 12, 14 maybe. Then it's if it's 14, then I will look at this. And similarly, for 3, what is the highest power? Something less than 14, but whatever it is, you calculate it. Maybe 10. And then similarly, for all the prime. You don't need to do it for non-primes, right? You do the same kind of thing. What happens when you expand this expression? Any ideas? Do you get this? Do you get all these terms at least? I shouldn't say at least. Does this product contain all these terms? It's not a good thing that it contains all of them, but does it contain all of them? It will. It will, right? Because for anything you can think of, right? You take the denominators, you take their prime factors, right? That combination of prime factors you can achieve by taking the appropriate things from 2, appropriate things from 3, and so on, right? Is it okay? I don't think this point is hard, but different people will see it in different ways, so you may not see it directly. So for example, I mean, you see that anything will be, probably it's easy, like maybe 7 square. 7 square will come like 14 and 7, so can come this, and you'll get this by taking this, and when you go to 5 and then 7 square, you'll get it, right? So you get them, okay? But then is this going to give us the answer? Is this going to be equal to that sum? Yes or no?
No.
Can you just give an example to tell us exactly?
We're only multiplying with the denominator, like with pairs of 1 or trios of 100. We're not taking like 2 into 3 in the denominator.
I don't understand. 2 into 3 we will get in this summation. So see, can you tell me something which is not in this summation S2, but it is there in the summation S1? Anyone? I'll be interested in listening to the explanation also, but yeah, can you just tell the term?
Sir, could you repeat the question?
Yes. So see, you know that all terms in S2 are in S1. And you understand what we mean by terms. Right? When you expand, you get the terms. But I'm saying that S1 has more terms. So just tell me a term in S1 which is not in S2. Is there such a term? There should be. Because S1 kind of has all combination of powers.
1 by 2 raised to 14 into 3 raised to 10.
That will come in the last one. If you take the maximum ones, you will not succeed, I think. You will always get them in the last term. That is not a problem. So this 3 raised to the 10, you understand what that means. It's probably not 10, but so we can just calculate it. 3, 17 by, so no, that is for the 17 factorial. That is basically these are precise endpoints. That you will not be correct if you take them, right? 9 and then this is, so it's not 10, it's much less than 15. 9 ones are 9, 2, 6, 6, it's just 6. No, that will not work. So let me first make this clear. How are we taking the last terms? We are taking the last terms according to what necessitates us, right? Because we need that to make sure that all the factors of this will come, right? When you multiply that. But the point is that all the combinations will not come in those terms. Any explanation for that? If we just give a counter example, that's all. Let's think, let me think, let you also think. Like maybe very small, very big, something like that. I mean, I think just take 2 to the 14, right? That does not come alone, right? Does it come alone? No, it doesn't. No, 2 to the 14 comes because 17 is odd. So like 2 to the 14 is there in S1, right? 1 by 2 to the 14 is there in S1. But 1 by 2 to the 14 is also, oh, no, sorry. Yeah, that's correct. That's it. Sorry, yeah. 1 by 2 to the 14 is one of the things. Yeah, so if you take all the endpoints, you don't succeed. But if you take like 1 by 2 to the 14 from this one and take ones from the other, then obviously you don't get it. That term will not appear in S2. So S2 has many more terms. Sorry, S1 has many more terms. S1. Is that correct? So that's why it doesn't work, right? So S1 is more a number theoretical object. Okay. This one is more of a number theoretical object. And this one is more like a combinatorics thing. I mean, sometimes they can become same, and that's when good things happen maybe, but here they are not the same. I hope that is okay. I just want to end with this point, and sorry, today I only solved 2 questions, but we will solve more tomorrow, and maybe Nagesh, you will start with 1 question tomorrow. But
Sir, can we have the class at 8:30 because I have an exam on Monday?
tomorrow 8:30,
Yes.
starting from 8:30. When do you have your exam?
No, sir, I have an exam on Monday, so I just wanted to finish fast.
Oh yes. Yes, actually Sundays I don't have a problem. Does anyone have a problem? No? Then we'll start at 8:30, but please don't forget. Please write it down, okay? Yeah, I will not forget. Okay, I just write it down. I'll also write it down now. Okay. But then I'm assuming since nobody says anything, is assuming that it's no problem. But then just last thing I want to say is that what is S1? Is it an interesting thing? Well, it is interesting because you can find its value. One of the things is that it's interesting in that way. Can you, and that's why I was thinking that this question might be this, because you can actually find the value of S1, right? It's not very difficult. You just have to compute some geometric progressions. So what is it? 2 to the minus 14 minus 1. You know better than me this thing. This is just, and you can do it. It's just a geometric progression. You know the ratio and everything. Calculate it for yourself. So this is a nice thing, but it has a meaning also. Can you say what is its meaning? So you look at this number, you look at the number 2 to the 14, 3 to the 6, and similarly, you understand what I'm saying. What am I saying? 5 to the power something.
Shubham, can you tell me the example that doesn't come in S2 again?
Yes, yeah, 1 by 2 to the 14. So it comes in S1. You see that? It clearly doesn't come in S2 and it comes in S1, right? So that's the point. It is, yeah. Then, but if you look at this number, 2 to the 14 times 3 to the 6, 5 times 5 to the something and so on, what is this number? Well, it is 17 factorial. That's how we made it. That's how we made it. It is a 17 factorial. So basically, you look at the number 17 factorial, and then you ask, what are the sum of the reciprocals of the divisors of 17 factorial? Sum of reciprocals of divide. Probably we should read it the other way. Divisors of 17 factorial, take their reciprocals and take the sum. That is S1. You know that is true. That is what we are doing. Because all possible combinations when you take of these, this is how you'll get all the divisors and nothing more. Right? Anything you get in this product, when you expand this, every term, the denominator is just a divisor of 17 factorial. Right?
Yes.
Okay. Now we can generalize this, and this becomes a number theoretic function, arithmetic function. It's a standard thing. You take any number p, but please maybe someday I'll ask the proof of this. Think about this matter. Not giving any homework, but this will come up in your Olympiads, you'll see. And this thing, we'll do this systematically also. If you look, if n is I'm trying to say that there's nothing special about factorial, is it? No. Factorial helps you to find those powers nicely, but the theoretical result is that if n has this thing, okay, and let's forget about the reciprocals for a second. If you just want the sum of divisors of n, let's call this sigma for sum and n. This is a function of n, right? Then what is this? Now you know, is just nothing to hide here, right? You know this. Yeah, that's the beautiful thing, that it factorizes, because you're taking all possible things, and such things factorize. Because you've learned that when you multiply, you take all possible things and multiply the monkey branches, right? All possible you take when you multiply out. And so when you do see all possible, then you know you can factorize. Okay? So that's all. This is the answer. Nothing more, nothing less. That's it, right? Now, if you say sum of kth power of divisors of n, let's call this. So you take the divisors, you take the kth powers, and then you take the sum. Okay, this thing will be what? Nothing special, right? It is just that as if you are taking the kth power on the number. But it doesn't make much sense if n is negative. But this makes sense, kth power of the divisors. I'm taking the divisors, I'm taking its kth power, right? and then it is, and similarly you go on. Is it right? Yeah, it's just P1 gets replaced by kth power, because you understand. And what we did earlier was -1, right? When it is reciprocal, then it is -1, and that's why it was power was -1. That is it. So this is nothing. Okay, so you can, maybe this is the one thing that you can do. Okay, so that brings us to the end for today. And okay, so we'll meet tomorrow at 8:30. So we only solved 2 questions, but okay, we learned something. So yeah. Okay then, goodbye, take care. We'll meet tomorrow.
Yes.
Okay, good night.
Bye, sir.
So yes, 1 minute. I'll just drink some water and come. Okay. And yeah.
Hello, can you hear me?
Yes, I can hear you.
এই একটু ভলিউমটা কম করো না প্লিজ। আরে একটু ভলিউমটা কম করো।
Yes. Yes, so I was saying that I'll just drink some water and come. Okay.
Yeah, sure.
And yes.
Yeah. Can you hear me?
Yeah, so let us start.
Yeah, so actually tomorrow I have my presentation at 9:30 and
Yes.
I'm going to present the thing that I'm studying, but it's not the presentation because my interview is actually end of December, 30th December, so I have 2 weeks time. So I've decided that I'll finish the thing that I am studying and then in 2-3 days and then I'll start. But it's a good thing that I'm studying and present. Lots to run, some category theory are there that I hope you will be able to contribute. There are some theorems that are like totally category theory and number theories just use it, so you might able to give some insights to there. And so yeah, so tomorrow 9:30.
Okay, so your presentation is at the end of the month. So what will you be presenting tomorrow?
Tomorrow I'll be presenting some basic homological algebra, homology,
Oh,
cohomology,
so it'll
basic.
be different from, okay, yes, you can do it. Yeah, certainly. Right. Yes.
Huh.
I can say one more thing is that because your presentation is on the 30th, I'm not trying to make a big deal of your presentation that, oh, it's some, no. I'm just saying that your presentation is on the 30th. Today is the 17th. So maybe you can say, okay, let me do one thing. Let me maybe give 2 talks, two times you can present me your presentation. Something like, build up to it or whatever you can think. Okay.
Yeah, but I
And
have still 2 weeks, so if I just start even like from Monday, so
yes,
I
that's
can,
it. That you will do what is it's up to you in the sense that, but just plan it properly so that it will be nice. And so, but tomorrow, what will you be presenting?
like I said,
Like any
uh,
precise plan? If like, what do you, how a series and so yeah. So okay, I'm not asking you to give me a plan
we'll
now.
see. I will see. I don't have
Yes.
a plan. I'm just
Okay.
I'll present whatever I'm studying.
Okay,
So
that is also fine.
it's kind of like a group study thing, like
Yes, that
uh,
is.
it's not here in Indian universities, but abroad, like some students they form a group, they form a Zoom meet, and then one of them present like whatever they are studying and their insights. So
Yes, that
yeah,
is fine. If it is just whatever you are studying, you want to do, yes, that is, yes. So we'll do that tomorrow. I don't know.
yeah.
Yeah, but I was thinking that because you plan to present the modular form thing, you could have also just presented it and be done with it. But okay, it's up to you. That different people
No,
do things in
you
different
only
ways.
said like finish it, so I thought okay, I can finish this in 2-3 days, and then I'll still have 11 more days, so I can even present I can easily present twice in 11 more days, like with the gaps of 3-4 days. in
Yes.
between.
So yeah, so you plan it accordingly. Okay, so let us begin. Okay, it's we should not maybe record this one now. This is just